Hey everyone, it's Mr. Glover here. Just about to do our next set of notes. So the topic of today, it's called Interpreting the Discriminant. And the idea is that you can zoom in on a portion of the quadratic formula without actually solving it, and then you can figure out the number of solutions. You won't get the solutions, but you can quickly find out how many. And this sort of saves us some time. So remember, a quadratic equation may have up to 2 solutions. You could have 2, you could have 1, you could have 0. We can tell from the graph of the corresponding function, or technically quadratic function. This was kind of what we talked about yesterday. If you have a situation where a quadratic function crosses the x-axis in 2 places, well, your equation will have 2 roots or 2 zeros. Those are both going to be solutions. This would be your 2 solution example. If you have a quadratic function that touches in 1 place, well, that's only going to have 1 solution. And there is the possibility that it doesn't cross the x-axis at all. You could have a quadratic function that just exists up here, never crosses. This one has no solutions. And actually, I should be cautious, no real solutions. We can also tell the quadratic formula, or from the quadratic formula, we're solving. So we can actually go ahead and we can go and solve the quadratic formula, and that will tell us the number of solutions. So for example, in this question, a is 1, because it's 1x squared. 2x means b is 2. And minus 8 means c is negative 8. So if we go to do the quadratic formula, x equals negative b, so negative 2 plus or minus the square root of b squared, so 2 squared minus 4 times 1 times negative 8, all over 2a, so all over 2 times 1. This will simplify to negative 2 plus or minus the square root of 36 all over 2. This will simplify to minus 2 plus or minus 6 over 2. So this one is going to give us 2 solutions. One's going to come from the plus, one's going to come from the minus. Let's look at the next one. X squared plus 2x plus 1. Well, in this case, x is, or a is still 1, b is still 2, but c now is 1, not negative 8. This one, using the quadratic formula, x will be negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 1, all over 2 times 1. This simplifies to minus 2 plus or minus the square root of 0, all over 2, which simplifies to minus 2 plus or minus 0 over 2. This only has one answer, or one solution. Minus 2 plus 0 is the same as minus 2 minus 0. So in this case, there's only one possible answer, one solution. Last example here, we have a still equal to 1, b still equal to 2. But now c is equal to 6. So the actual quadratic equation, x will be negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 6, all over 2 times 1. This simplifies to negative 2 plus or minus the square root of negative 20 over 2. And now we've got a problem. We can't take square roots of negative numbers. So because of this, I know this has no solution, or no real solution. And it all comes from the negative 20. So I think hopefully we should be seeing a pattern here. The first example we did, we had a square root of 36, that led to 2 solutions. The second one, we had a square root of 0, that led to 1 solution. And the third one, we had a negative square root, which led to no solution. So it all lies in the square root. All the information we need to know about whether we can solve it has to do with what's in the square root. And the term inside the square root has a special name. It's called the discriminant. So instead of completely solving the equation, we can tell how many solutions an equation has by analyzing the discriminant. And this is the term under the root. So in the quadratic formula, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So our discriminant, the thing we're interested in, is b squared minus 4ac. So if b squared minus 4ac is greater than 0, then we're going to have 2 solutions. If b squared minus 4ac is equal to 0, we're going to have 1 solution. And if b squared minus 4ac is less than 0, we're not going to have any. There will be no real solution. So instead of going through this whole process, we can just use the discriminant to quickly figure out whether or not we'll have a solution or how many solutions we'll have. So let's try some problems. Determine the nature of the roots of minus 2x squared plus 3x plus 8 equals 0. So we want to just calculate the discriminant. B squared minus 4ac equals 3 squared minus 4 times minus 2 times 8. That's going to be 9 plus 4. Or sorry, it's 9 plus 64, which works out to 73. Because we have a positive non-zero discriminant, 73 is greater than 0, this one has 2 solutions. Moving on, 3x squared minus 5x equals negative 9. Now this one, you've got to be really careful. Remember, to use the quadratic formula, you need to move everything to the other side. So we're going to move the negative 9 over by adding it to both sides. This is going to change the formula or equation to 3x squared minus 5x plus 9 equals 0. So b squared minus 4ac is going to be negative 5 squared minus 4 times 3 times 9. In this case, it'll be 25 minus 108. Which is negative 83. Since we have a negative in our discriminant, well, this one has no solutions. Negative 83 is less than 0, so no solution. Or no real solution. Which leads us to the last question. So we can take this idea of a discriminant and we can use it to figure out criteria on a variable in our equation. So if we don't know what one of our digits is, well, we can just solve for what it has to be in order to have a root. And then we can set a range of values that it's allowed to be. So for this question, 2x squared plus 5x plus k equals 0. A is going to equal 2. B is going to equal 5, but C is k. We don't know what C is. It's unknown right now. But we also know that it has to have exactly 2 real roots. And what that actually means is that b squared minus 4ac has to be greater than 0. So if we use that idea, 5 squared minus 4 times 2 times k must be greater than 0, because our discriminant needs to be positive. So we can go ahead, we can simplify this a little bit. 5 squared is going to give us 25 minus 4 times 2 times k, so it'll be 8k greater than 0. We can now start moving some things around. We can move the 8k to the other side. 25 is greater than 8k. And now when you're working with a greater than or equal to sign, it's the same as if you have just the equal sign for algebra, but if you divide by a negative or multiply by a negative, you have to switch the direction. So I can do everything except that, and I will be fine. So I've added 8 to both sides, just like a normal equation. And now I need to get rid of my 8 by dividing by 8. So 25 over 8 is greater than k. So in other words, k must be less than 25 over 8 in order for the equation to have 2 real roots. So if k is less than 25 over 8, the equation will have 2 real roots, real solutions. And that's all based on whether the discriminant is equal to, greater than, or less than 0. So this is a bit of a shorter section. The quadratic formula section is a little bit of a longer one. The idea with this one is just about having a quick check to tell us whether something works or whether something won't work. There's no point going through the whole quadratic formula if the discriminant gives you no solution. So if you start the problem by just checking the discriminant, you can skip some steps. And if the question asks you how many solutions does it have, well, use this, don't use the whole formula. So I have some problems for you. It's page 251 out of your workbook. Questions 4, 5 to 7, you only have to do A and C for 5 to 7, 8 and 13. So I think I will end things here. I hope everybody has a great rest of the day, and I hope to see everybody tomorrow when we do our Zoom session. So take care. Bye for now.